I'm reading the activity lifecycle from Android.com. Understanding the activity lifecycle. As the user navigates throughout and back of your app, the activity instances in your app transition through different states. The activity class provides, and it's a class, provides a number of callback that allows the activity to know that the state has changed. The system is creating, stopping, and resuming activity or destroying the process in which the activity resides. With the lifecycle callback method, you can declare how activity behaves when the user leaves and re-enters the activity. For example, if you're building a streaming video app, you might pause the video and terminate the network connection when the user switches another app. When the user returns, you can connect the network and allow the user to resume video from the same spot. In other words, each callback allows you to perform specific work that's appropriate to a given change of state. Doing the right work at the right time and handling transition properly makes your app robust and performant. For example, good implementation of life cycle call. I'm going to go deeper into this callback. It's a technical word. Can help you ensure that your app avoids crashing if the user gets a phone call or switches the app, consuming resources when the activity is not used, losing user progress if they leave your app return later, crashing or using your screen rotates or landscape models. Okay, now this document talks about activity life cycles and callback. Let me tell you something about what a callback is. Okay, so callback, also known as call after function, is an executable code that is passed as an argument to another code. And let me show you callbacks in Python because this comes along a lot of time. A callback is a function provided by the consumer of an API that the API can then turn out and invoke, calling back. I set up a doctor's appointment. I can give them the phone number so that they can call me. The callback is all like that, just a phone number. It's an arbitrary instruction like send me an email, also. Callback are used in situation where an action is asynchronous. If you need to call a function and immediately continue your work, you cannot sit there to wait the return. When the function is done completely, its asynchronous work will be then invoke your callback with some predetermined argument. Okay, now let's look at some series. Plain function or a callback function. Simple Fibonacci series, question divide by 7, safety, callback function. Here it is. Now the Fibonacci function now looks like it accepts parameter CV, which is expected to be a function, and once we have calculated the new element in the series, we can call back the function which in time. Also, this is similar to recursion. The return value is expected to be list or tuple in which the first element is true or false, indicating we have found the answer or not. Based on this callback function, we must accept a single value, return a tuple in which the first element is true or false. The callback function looks like this. It accepts the current value of the series, return true and false. Not very clearly mentioned, but it's like a function going inside and then we get something back. We'll see again because these things require iterations to learn. To navigate transition between the stages of activity of a life cycle, the activity class provides, and always remember when you see class, it's like a code, provides a core of 6 callbacks: on create, on start, on resume, on pause, on stop, and on destroy. The system invokes these callbacks as an activity enters a new state. Figure 1 represents visual representation of this paradigm. Activity launched, on create, on start, on resume, activity running. On pause, user returns to the activity, and on resume, it comes back. On stop, user navigates. On restart, it comes to on start. On stop, apps with higher priority needs memory. App killed, user navigates to the activity. On create, the activity is finished or being destroyed by the system. On destroy, and call the shutdown. Lifecycle callback. This section provides conceptual and implementation information about callback methods during the activity lifecycle. Some actions like set content view belong to the activity lifecycle method themselves. However, code implements the action dependent component should be placed in the component. So to achieve this, you must make the department component lifecycle aware. On create, you must implement this callback which fires when the system first creates the activity. On activity creation, the activity enters the creation state. The on create method you perform basic application logic that should be done only once. For example, you implemented on create might bind data to the list, associate the activity with Viewmodel, and instantiate some class scope variable. This method receives the parameter saved instant state, which is a bundle containing activity previously saved state. If the activity has never existed before, the value of it. Many things talked here. Let's see. On create, the method you perform basic application startup logic that should happen once you enter live state. For example, implementation of on create might bind your data to the list. This is the concept called binding of data. Okay, and associate the activity with the view model and instantiate some class scope variables. This method receives the parameter save instance states, which the bundle object containing the activity states. If the okay, so let's go there. View model. View model is the class that is responsible for preparing managing data for activity on a fragment. And now we have to understand what is a fragment. The view model is always created and associated with the scope. In other words, the view model will not be destroyed or system configuration change, and so on and so forth. And then we have fragments. Okay, now skipping something, we have Kotlin code and we have Java code. So Kotlin is more simpler, I think, in a way. Let's see, override function, bundle text.view. Both are the same, but yeah. And then you have the Kotlin code on start, on resume. Have the Java or the Kotlin code. I think I would rather start with Kotlin than Java if I'm doing the first time. Okay, this was very quick about the activity lifecycle from the Android help.